Hey there, second period, seventh period, and eighth period. This is your review video. I so want you to do well on this quiz to start the quarter. I hope you take it serious. You've got the other review videos. You've got those cluster problems. You can email me over the weekend. All right, please take advantage of it. Please do your best. All right, we're just going to do 4 really quick problems here. Problem number 1. What kind of problem is this, Kiona? Yeah, that's right, Keon. It's a double distribution problem. So I'm going to do it the long way because I know how many of you do it this way. I know Josh Gerda does it this way. I know some other people do it this way. And they get it right. Well, if it's going to allow you to get it right, then don't be lazy. Do it this way. Okay, now not everybody does it this way. I personally don't. But I get it right. So you do it the way that's going to allow you to get it right. So now I'm going to distribute. I'm going to go 5 times 3 is 15. And I'm going to go 5 times, oops, yeah, no, I did that right. 5 times rad 13, well, that's just a positive 5 rad 13. Okay. Now I have to distribute in this quantity. I've got a negative 2 rad 13 times 3. Well, that's going to be a negative 6 rad 13. And here, this one seemed to be giving people trouble. It's really pretty simple. I'm going to rewrite it over here as negative 2 rad 13 times rad 13. And since there's only one rad 13 there, I'll put a little 1 in front of that. Now, when we did these kind of problems in class, you guys aced them. You were so good at them. As soon as they showed up inside another problem, you couldn't do it. Didn't understand that. So let's rewrite it and make it just like the ones you got right and see if we can't translate that into some success. So I do negative 2 times 1 and I get a negative 2. Now I do rad 13 times rad 13. Well, that's just plain old 13. Negative 2 times 13 is negative 26. So I'm going to write a negative 26 at the end here. Now, Kevin Merrick will tell you it's time to combine like terms. That's right, Kevin. All right, so let's put a 15 and a negative 26 together. Those are like terms. And let's put a 5 rad 13 and a negative 6 rad 13. All right, so 15 minus 26, I think that's going to be a negative 11, right? Negative 11. And a positive 5 and a negative 6 is going to be a negative 1 rad 13. And there you go. There's the product from the double distribution. All right. Number two. We're going to find the perimeter and we're going to find the area. We're going to do the perimeter first. Perimeter is cake. Perimeter is cake. All we're going to do, and some of you like to really do this, and I think it's a smart idea, you write the dimensions on all 4 sides. We're going to add up our rational numbers. I'll tell you what, I'll even highlight my rational numbers in yellow. So this is rational, this is rational, this is rational, and that's rational. Some of you are thinking this 3 is rational. It's not, because it's a 3 rad 5. 3 times the square root of 5. Square root of 5 is irrational, therefore 3 times the square root of 5 is irrational.
Aaron,
all right.
Aaron, don't forget to stop in the office.
Let me highlight my irrational numbers. Okay. And let's see here. Okay, I've put them all together. All right, so let me add up my yellow ones. I'm going to get 13, and 13 I'm going to get 26. My irrationals, I've got 3 rad 5 minus rad 5. So now I'm down to 2 rad 5, aren't I? And over here, I'm going to get a 2 rad 5. And 2 rad 5 and 2 rad 5 is 4 rad 5. So my perimeter is going to be 26 plus 4 rad 5 inches. Pretty simple stuff. Don't make this hard. All right, let's do the area now. All right, the area is going to be just like the problem I did in problem number 1. It's a double distribution problem. We're going to take 7 plus 3 rad 5, and we're going to multiply it by 6 minus rad 5. Oop, that doesn't look like a rad 5 there. Hold on a second. So 7 times 6 is 42. I'm sorry. I should have written it out. I should write it out for you. So we're going to do 7 times the quantity of 6 minus rad 5. And then we're going to do plus 3 rad 5 times the quantity of 6 minus rad 5. If you want a 1 in front of there, you go ahead and put it in. Okay. So now I'm going to multiply 7 times 6, get 42. 7 times negative 1 rad 5, negative 7 rad 5. Going to distribute here. 3 rad 5 times 6 is going to be 18 rad 5. I'll write it vertically this time because some of you would rather do that. And then I'm going to do 3 rad 5. Oops, that's one of those that some of you have trouble with, so I'm going to rewrite it. 3 rad 5 as a quantity times a quantity of negative 1 rad 5. And then I'll multiply from there. All right, 3 times negative 1, negative 3. Rad 5 times rad 5 is 5. Negative 3 times 5, negative 15. And so I'll write my negative 15 over here. So my area will be found by combining like terms. 42 minus 15, I believe, is 27. And 18 minus 7 is 11 rad 5. And that will be inches squared. So my area is the quantity of 27 plus 11 rad 5 inches squared. All right, this one here. Sorry, this all moved on me and I'm all confused now. Let me do that. There we go. This one here, we're going to do two things. We're going to find x. We're told the area of this square is 98 centimeters squared. We're going to find x, and then we're going to find the perimeter. Okay? So, remember, to find area, we multiply the base times the height. Well, in this case, it would be x times x, and that'll have to equal 98. Well, x times x is x squared, right? So x squared has to equal 98. Well, how do you undo an exponent? You use a root. Since it's squared, we use the square root. But we're actually only using the rad because we're only interested in the positive square root. We don't care about the negative. So, rad of 98, I need my perfect squares here. Let me see, I need a perfect square that goes into 98 evenly. So let me list my perfect squares out. I've got 1, 4, 9, 16, 25, 49, 64, 81, and I don't have to go any higher because they're bigger than 98. So now I'll check and see, and if I need to use a calculator, check it's okay, but I'm not going to type in the square root of 98 and get a decimal approximation. That's not what I'm going to do. So 81, does it go into 98 evenly? No. 64 does not. 49, I think it does. I think it does. Yeah, I think it's going to go in twice. Yeah, it is. So this is really the square root of 49 times 2. Well, if you want to do the dating thing, you've got a pair of 7s there. X is going to equal 7 rad 2. So x is going to equal 7 rad 2, and I think we're in centimeters. Well, now to do the perimeter, it's going to be easy because there's going to be 4 of those, aren't they? Aren't there? Aren't there going to be each side, since it's a square, going to be 7 rad 2? So I've got a couple choices. I could do 7 rad 2 plus 7 rad 2 plus 7 rad 2 plus 7 rad 2, or I could do 4 times 7 rad 2, and 4 times 7 is 28 rad 2, and that will be centimeters. There you go. All right, one last problem. Did a couple of these. I thought I'd throw one more on. Remember, I'm going to do 5 times 2 and get 10. Here, I'm going to get rad 13 times 36. And remember, I talked extensively in class Thursday, but not, oh, that's not supposed to be a 36. I'm sorry, it's supposed to be a 39. Silly me, let me fix that right away so I don't confuse you. I'm glad I caught it. Apologize for that. 39. Okay, so remember I talked extensively in class about not actually multiplying. Look, I'm going to be taking this apart anyway. I could do 13 times 39, which, let me see here. I'll multiply it over here and I'll show you how futile it is. All right, 3 times 9 is 7, carry the 2. There's 9, 18, and 2 is 0, carry the 2. I believe it's 507, 39 times 13. Yeah, now, I don't know about you, but I would rather simplify the rad of 13 times 39 than simplify the rad of 507. It's a lot less work because I see that 39 is really 13 times 3. Well, look at that. I got a pair of 13s there. So I'm going to have a 10 out front, right, from here. I'm going to have a 13 out front, right there. And then left and side is just going to be a plain old 3. 10 times 13, 130 rad 3. Okay? If you need some help with that, please, please, please contact me. All right. That's it for the video. Mr. Laurence signing off. Have a good night, everybody.